In section 11.2, we're solving quadratic equations by the quadratic formula. Our objectives are to solve quadratic equations by using the quadratic formula, determine the number and type of solutions of quadratic equations by using the discriminant, and to solve problems modeled by quadratic equations. A quadratic equation written in the form ax squared plus bx plus c equals 0 has the solutions given by the quadratic formula x equals, in the numerator, negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a. It's a really good idea to memorize this formula by repeating it over and over, writing it on a note card, or even learning a song that will help you memorize the quadratic formula. There are plenty out there on YouTube, so check them out. Let's use the quadratic formula to solve each of these equations. We have each one in the form of ax squared plus bx plus c equals 0. So we identified the values of a, b, and c and plugged them into the quadratic formula. In the first example, x squared plus 5x plus 6 equals 0. We know that a is the coefficient of the x squared term, which is 1, b is the coefficient of the x term, which is 5, and c is the last constant, which is 6. We're plugging each one of those into the quadratic formula, where we have x is equal to the opposite of b, negative 5, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Be careful when simplifying the quadratic formula, making sure that you follow the order of operations and find out exactly what's under the radical and simplify using the appropriate algebra techniques. When we simplify what's under the square root, 5 squared is 25, minus 4 times 1 times 6, minus 24. We get plus or minus the square root of 1 all over 2. So this can be written as negative 5 plus or minus 1 over 2. We find our two answers by using this formula with a plus sign and then using the same formula with a minus sign. So we get x equals negative 5 plus 1 over 2, which is negative 4 over 2, or negative 2. And the other solution is x equals negative 5 minus 1 over 2, or negative 6 over 2, which is equal to negative 3. So these are our two solutions to this quadratic equation, and you should check each one of those by plugging each one into the x and verifying that each one of those results in a true equation. So we can leave our answers as x equals negative 2 or x equals negative 3, or we could write it using the solution set where the solutions are negative 2 and negative 3. And go ahead and check those to confirm that we do have the correct answers. Now let's solve example B. X squared plus 4x minus 7 equals 0. We can identify that a is equal to 1, b is equal to 4, and c is equal to negative 7. Then we plug them into the quadratic formula where x is equal to negative b, or negative 4, plus or minus the square root of b squared, 4 squared minus 4 times a times c, or minus 4 times 1 times negative 7 all over 2a. I like to simplify everything that's under the radical first, and that will give me negative 4 plus or minus the square root of 44 all over 2. But this can be simplified. The square root of 44 is the same thing as the square root of 4 times the square root of 11, and we know the square root of 4 is 2. So this is written as negative 4 plus or minus 2 square root of 11 all over 2. And then we can write this as, we can divide each one of these terms by 2 to write it as negative 4 over 2 plus or minus 2 square root of 11 over 2. And then it could be further simplified to negative 2 plus or minus the square root of 11. So one answer is x equals negative 2 plus the square root of 11. And the other answer is x equals negative 2 minus the square root of 11. Again, you should check your answers by plugging those values back into the original equation for x. Do it twice and you'll see that both of those are solutions to that quadratic equation. To solve example D, we have 5x squared equals negative 10x minus 3. We need to get it into the correct form first, where the correct form is where the quadratic equation is written in the form of ax squared plus bx plus c equals 0. So we need to first add 10x to both sides of this equation, as well as add 3 to both sides of this equation so that we get one side is equal to 0. And doing that, on the left side we get 5x squared plus 10x plus 3 is equal to 0. Now we can identify the a, b, and c parts of the quadratic equation, where a is equal to 5, b is equal to 10, and c is equal to 3. By plugging that into the quadratic formula, we get x equals the opposite of b, or negative 10, plus or minus the square root of b squared, 10 squared, minus 4ac, 4 times 5 times 3, all over 2a, or 2 times 5. Let's simplify. Be very careful here. You want to make sure you don't skip any steps. Take your time so that you get it correct. We get negative 10 plus or minus. The 10 squared minus 4ac, that's all going to simplify to the square root of 40 over 10. And the square root of 40 can be simplified because 40 is 4 times 10. The square root of 4 is 2. Oops. We get 2 times the square root of 10 all over 10. Now we can break this up into two fractions where we have x equals negative 10 over 10 plus or minus 2 square root of 10 over 10. So we can write this as x equals a negative 1 plus or minus the square root of 10 over 5. So again, you would check each one of those solutions, one with the plus, one with the minus, and plug them back into the original equation for x to confirm. Let's look at example E. We have 5x squared equals negative 8. We need to make sure it's set up in the appropriate form for the quadratic formula. We need to add 8 to both sides, so that we get 5x squared plus 8 is equal to 0. Now we can identify the a, b, and c, where a is equal to 5. B is going to equal 0. B is the coefficient of the x term. Since this does not have an x term, the b is equal to 0, and c is equal to 8. By plugging those three values into the quadratic formula, we get x equals negative b, or negative 0, plus or minus the square root of b squared minus 4 times a times c, 0 squared minus 4 times 5 times 8, all over 2a, 2 times 5. Now this simplifies to x equals 0 plus or minus the square root of negative 160, all over 10. Now this can be simplified. We're going to have an imaginary number, so we have the square root of negative 16 times the square root of 10. That's going to be 4i square root of 10 over 10. Remember that we should also have a plus or minus here. When we simplify this, we get x equals plus or minus the 4 over 10. We can reduce to 2 over 5, so we get 2i square root of 10 over 5. So one of these solutions is x equals the positive 2i square root of 10 over 5, while the other one is negative 2i square root of 10 over 5. Again, you can check both of those by plugging them back into the original equation to confirm that those are indeed the correct answers. In example G, we have x squared over 18 plus x plus 35 over 9 equals 0. This is a quadratic equation, and we can use a quadratic formula to solve. But to make it a little bit easier, since we have fractions in our problem, we can multiply both sides by the LCD to get rid of those fractions. So we can multiply both sides of this equation by 18, and when we distribute, that's going to eliminate those fractions. So 18 times x squared over 18, we get x squared, and then we distribute the 18 to the second term to get 18x, and then 18 times 35 over 9 is 70. So now we have a quadratic equation where we can use the coefficients where a is equal to 1, b is equal to 18, and c is equal to 70. And remember the quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And using those values for a, b, and c, 1, 18, and 70, we get x is equal to negative 18 plus or minus the square root of 18 squared minus 4 times 1 times 70, all divided by 2a, or 2 times 1. When we simplify this, we get x equals negative 18 plus or minus the square root of 18 squared, do the power first and multiply before you subtract to get 44, all divided by 2. Now the square root of 44 can be simplified. So we can write this as negative 18 plus or minus the square root of 44 is simplified to 2 times the square root of 11, all divided by 2. We can divide both of these terms by 2 to get negative 18 divided by 2 plus or minus 2 square root of 11 divided by 2. And then we simplify that to get negative 9 plus or minus the square root of 11. So we have two answers here, one with the plus and one with the minus. And we can check those by plugging in the values into the original equation for x. And then you will check and see that they're both solutions to that quadratic equation. For these examples, we're going to use the discriminant to determine the number and types of solution of each equation. Whenever you have a quadratic equation, it's possible to have one solution, two solutions, or no solutions in terms of real solutions. And a way to determine that without solving through the entire quadratic formula is to use the discriminant. The following table corresponds the discriminant, which is the b squared minus 4ac, that portion of the quadratic formula, of a quadratic equation of the form ax squared plus bx plus c equals 0, with the number and type of solutions of the equation. So if you find b squared minus 4ac is positive, then you know that you have two real solutions. If b squared minus 4ac is 0, that means you only have one real solution. And if b squared minus 4ac is negative, then you have two complex but not real solutions. So you're taking the square root of a negative number, so you have imaginary complex solutions. So let's identify the discriminant for each one of these. In example A, 4x squared minus 8x plus 4 equals 0. Since it's already in the form of ax squared plus bx plus c equals 0, we can identify A as 4, b is negative 8, and c is equal to 4. And then by finding b squared minus 4ac, that's going to be negative 8 squared minus 4 times 4 times 4. And that is going to be 64 minus 64, which is equal to 0. Since the discriminant is 0, we look at the table here. If the discriminant is 0, that means we only have one real solution. Okay. Now let's look at example B. Before we find the discriminant, it's important to write this in the form of ax squared plus bx plus c equals 0. We want a 0 on one side of the equation. To do that, we're going to subtract 2x from both sides, and we're going to add 5 to both sides of this equation so that we end up with 6x squared minus 2x plus 5 is equal to 0. Now we can identify the value of a, b, and c. A is equal to 6, b is equal to negative 2, and c is equal to 5. So the discriminant, b squared minus 4ac, is a negative 2 quantity squared minus 4 times 6 times 5. That is going to be negative 116. Since the discriminant is negative, we know that we have two complex but not real solutions. So we'll have imaginary numbers in our solutions. Okay, now example C, we have the quadratic equation x squared plus 8x plus 7 equals 0. We can identify the a, b, and c. A is equal to 1, b is equal to 8, and c is equal to 7. So using the b squared minus 4ac, that's going to be 8 squared minus 4 times 1 times 7, and that equals 36. So that means we have a positive number, so that means we have two real solutions. And then finally, example D, we have 10 minus 5x squared equals 6x plus 5. We want to make sure it's in the form of the quadratic equation equal to 0. And in order to do that, we have to subtract 6x from both sides and subtract 5 from both sides of the equation. And then we can rewrite this as negative 5x squared minus 6x plus 5 is equal to 0, where a is equal to negative 5, b is equal to negative 6, and c is equal to 5. Using the formula for b squared minus 4ac, we get, that's going to be negative 6 squared minus 4 times negative 5 times 5, and that is equal to 136. It's positive, so that means we have two real solutions. In number 3, part A, we want to solve by completing the square. Let's solve a geometry problem using a quadratic equation. Here we have a rectangular sign that has an area of 21 square yards. Its length is 6 yards more than its width. Find the dimensions of the sign. I like to begin with a diagram where we can label the length and the width. The width we can say is x yards, and the length is 6 yards more than that, so we can label this as x plus 6. And we are given information about the area. We know that the area of a rectangle is equal to the length times the width, and the area given to us is 21 is equal to the length of x plus 6 times the width of x. This is an equation that we could solve if we were to be able to write it as a quadratic equation in the form equal to 0. So let's begin by distributing the x, and we get 21 is equal to x squared plus 6x, and then I'm going to subtract 21 from both sides so that I get 0 is equal to x squared plus 6x minus 21. This is a quadratic equation. We can use a quadratic formula, and we can see that a is equal to 1, b is equal to 6, and c is equal to negative 21. Then we can use the quadratic formula. Remember the quadratic. So x is equal to negative b, that's going to be negative 6 plus or minus the square root of 6 squared minus 4 times 1 times negative 21, all divided by 2a, or 2 times 1. We can simplify this. Negative 6 plus or minus the square root of the 6 squared minus 4 times 1 times negative 21 simplifies to 120, all divided by 2. And the square root of 120 can then be simplified to x is equal to negative 6 plus or minus 120 is 4 times 30, and the square root of 4 is 2. So we can write this as 2 times the square root of 30 all over 2. Now this can be simplified even further by writing this as two fractions, so that we get x is equal to negative 6 over 2 plus or minus 2 square root of 30 over 2. So when we simplify that, we get negative 3 plus or minus the square root of 30. Now we want to make sure this makes sense for this particular problem. Since we have two answers here, we can look at when x is equal to -3 plus the square root of 30, and that is approximately 2.477, so it would be the length of about 2.477 yards, or the width. Or if we do x equals -3 minus the square root of 30, that's going to give us a negative answer. So it wouldn't make sense to use that negative value. So we can say the answer we get for x is -3 plus the square root of 30, because this ends up being negative. Now let's look at the dimensions. The dimensions is the length and the width. The length, we have x plus 6. The length is x plus 6. And we just found that the length, or the x, sorry, is -3 plus the square root of 30. So that's going to be -3 plus the square root of 30 plus 6. So that's going to end up being a +3 plus the square root of 30, which is approximately 8.477 yards. So let's go back to the diagram. And we can see that the width is x, which is approximately 2.5 yards, and the length is x plus 6, which is about 8.5 yards. And that would result in a sign that has an area of 21 square yards. In this geometry example, we're given that the hypotenuse of a right triangle is 7 feet long, and one leg of the triangle is 5 feet longer than the other leg. So if we let x represent one leg, then the other leg is going to be x plus 5. We want to find the perimeter of the triangle. So we have a couple things going on here. We know with a right triangle and a hypotenuse that with legs A and B and hypotenuse C, we can use the Pythagorean theorem that says a squared plus b squared is equal to c squared. What we want to ultimately find at the end is the perimeter. The perimeter of this triangle is going to be adding up all the sides, a plus b plus c. So when we plug in our given values that we know, a is x, so that's going to be x squared plus x plus 5 squared. That is equal to 7 squared. By simplifying and solving this quadratic equation, we'll be able to find the value of x, and that will give us one leg, x plus 5 is the other leg, and the hypotenuse is 7. Add those together to get the perimeter. When we simplify the next step, we are going to expand x plus 5, that's going to be x plus 5 times x plus 5 using the first, outer, inner, last. And we get x squared plus first, and the outer and the inner, 5x plus 5x, and the last of 25 is equal to 49. We want to simplify this, combine like terms. I'm going to subtract 49 from both sides and combine like terms. X squared and x squared gives me 2x squared plus 5x and 5x is 10x, and then 25 minus 49 is -24, and that is equal to 0. So here we have a quadratic equation, and we can solve by using the quadratic formula. However, I notice that all of these coefficients are even numbers, so I'm going to simplify this equation by dividing both sides of this quadratic equation by 2. I'm going to end up with x squared plus 5x minus 12 equals 0. And here we can use the quadratic formula where a is equal to 1, b is equal to 5, and c is equal to -12. So by using the quadratic formula, I get x is equal to the -b, -5, plus or minus the square root of b squared minus 4 times 1 times -12, all over 2a, or 2 times 1. This is going to simplify to x equals -5 plus or minus the square root of 73, all over 2. So let's double check each one of these, one with a plus, one with a minus, and see which one would make sense for this problem in terms of the leg of a right triangle. Let's look at what happens when we do the plus. The -5 plus the square root of 73 over 2. That results in a positive number, which is approximately 3.544. So we can say that that leg of the triangle is x, which is equal to about 3.5 feet. And then the b, it would be 3.5 plus 5, so that would be about 8.5 feet. So you would have a right triangle with those dimensions, and then the perimeter would be, this would be a rounded value. So you may want to get the exact answer here by using the radicals. That's going to be approximately 8.5, 10.5, 19 feet, approximately. So it would make sense that this x could be the length of the side of the right triangle. However, if we tried the x equals -5 minus the square root of 73 over 2, that's going to result in a negative number. So that wouldn't make sense as in terms of finding a length would not be negative. So we can say that the side A is x, which exactly would be -5 over 2 plus square root of 73 over 2, which is approximately 3.5 feet. And B is x plus 5, which would be the -5 over 2 plus 5 would give you +5 over 2 plus the square root of 73 over 2, which would be approximately 8.5 feet. And C is equal to 7. So when you add up to find the perimeter exactly, you add up all three of those to get the square root of 73 plus 7, which is approximately 19.1 feet for your perimeter.